I want you to imagine 3-4 years into the future, you have discovered a problem, something catastrophic, a missing part, something's broken, a quality issue, something has gone wrong. And you know this is going to cause a problem for the rest of your colleagues, for your manager, for other departments, for your sales team, your marketing team. Could be your customer that is going to struggle from this. Could be your customer's customer. All you know is that you have been the person to discover this issue. You could have caused it, or it could have been someone else. So you take yourself off to the little coffee place, the little kitchen in the side of your office, to take a deep breath before you disclose this and feel this bomb go off. You sit on the sofa and then take one last deep breath. And then, out of the corner of the room, you see this lamp, and then this smoke starts to come off it, and then whew, out of it, a genie appears. And you're really taken aback. What? These things actually exist? So you're really confused. What is going on? And the genie says, look, I don't have time to worry about this, okay? I just want to help you. I can see you're in a bad place, so I'm going to try and fix it. You're so taken aback trying to understand what is going on here. But then the genie says, look, I don't do the 3 wishes anymore. That's really old-fashioned. What I do is I can send you back in time, and I can give you the opportunity to fix everything you've done here. I'll send you back several years. How does that sound? And you're really thinking, well, I don't know, this is quite, hey, I need to know right now, like, do you want to do this or not? Hey, look, if your social life was great, you're gonna live it again. And if it was bad, well, then, you can try and fix that as well. So you think because of such a disaster you're going through, you know what, yeah, I would change it. I would go back. Okay, cool. But you're not gonna remember anything of this, all right? So you're just gonna be sent back and that's it, about 3 years or so. Okay, cool. And the genie clicks his fingers and whew, here you are, right now, in Coventry at the Engineering Design Show, listening to a guy talk about product design. You have been sent back from 3 years in the future, and let's solve that problem so that that never actually occurs. There we go. Right. First of all, I think it's important, I don't like to talk about myself, but I wanted to give you a bit of an explanation as to why I've got some stories and I've got some reasons that I'm able to share with you and do this presentation. I took a degree in electronic engineering. My graduate job was working for Sony. This is a company that has 100,000 employees or so, or even more. I was an RF engineer that worked on the tuner part of TVs. And that was my specific job. And that's obviously with quantities of about 5 million, so a massive amount, working in a large organization. Then I worked for a quite small company called Pambury, where there's only 11 full-time employees. In this company, I did everything from the 3D design, the simulation, the procurement of parts, the testing, the soldering, the whole lot, and also then going on to promoting it to prospect customers. After that, I moved into the world of connectors, which is amazing. I love this world of connectors, as you'll find out. That was working for Harwin, and then about 2 years ago, I started working for Powell. So what I want to do is use the experience that I've had from working in these large companies, this small company, and also what I've been doing in the world of connectors. So my job is to go out and help design engineers. My job is to know as much as I can possible about products so that when there is any issues or you're trying to solve a design, my job is to try and help people. And then because of that, I've visited hundreds of companies. And during this time, I have found so many lessons, ways that people are working, different solutions that people are having in completely different industries that could be helpful for someone else. So what I want to do is share some of these stories with you today, which hopefully should help you moving forward. This is some of our technical partners to give you an idea that we have all of these tools available to try and help people. That's what I do. Hopefully that will give a backdrop and a background as to why I'm here. But also, who's a design engineer in here? Raise your hand, please, if you're design engineers. Okay. And anyone involved right at the start of the project who's in that concept phase? Anyone else who's there who's right at the start? All right. What I want to let you know is that you are a very powerful person. You have the tools available for all of those issues that when you would have spoken to that genie in 3 years, all of the other problems that you could potentially cause for procurement managers, you have the power to avoid this and make everything streamlined. Feel proud of that you're in now. Feel proud of that moment where you are in your career. You have this opportunity. Make use of it. Why do I explain this? This is a very simple graph, as you can see. Imagine that this is a project timeline, right at the start, and then you're making changes going through it. And then this is where you would have different stages, where your prototype stage, your mass production stage. And obviously, the further you go into a project, the harder it is to make a change. And when you get further towards, for example, the production stage, if something goes wrong, say it's during the final testing, to make a change then, you're maybe pulling engineers off other parts and pulling them back into this existing project. The cost of this dramatically changes. Dramatically increases. So if you're going to make any changes at all, doing it right at the start is the very best time you can do it. It's the most affordable way that you can help this scenario. Now, I actually rewrote this presentation several times because I was trying to think of what's the key messages I wanted to give to you all. What have I gathered from these multiple visits that I've done with people, these different lessons that I've learned? What have I come up? And in the end, I came up with these 4 things, these 4 points that I consider every time when I'm recommending a component or a solution to a new design. Number 1, is it doing what it's meant to do? This is the fun bit. This is where you have the problem and you go and look for the solution. You look in the catalog, you search on the internet, you do the research, the fun bit, what we're actually doing. And each of these I'll go into a bit more depth in a minute. Something that sometimes gets forgotten. How is it being put into the product? If whatever component you're actually doing, how is the production manager going to put that into the product? When there's a maintenance and something needs to be changed, be it during the design or be it when it's already been out in the market and you need to change it, how is that being taken apart? And that's something that does actually get forgotten about during the design phase, which is easier to consider when you're right at the start choosing the component, rather than later on when they start getting towards the production stuff. Is it cost effective? Something that I find when I speak to some design engineers, they don't have an idea of how much a component should cost with regards to the rest of the device. And they're also not aware of tools that they can have, which I'll go into in a minute, that can actually reduce the costs quite significantly. And finally, where is it actually going to be purchased? Where is that supply chain after that it's been bought in? So when your product has been designed right from the start and you've made the design, it's gone through the prototype stages, gone through the testing phases, gone through ready for that production stage, and it gets passed to whoever is your procurement manager, where are they actually going to get it from? And if that was also considered right at the start, it would help out the rest of your team. It would help out with delays so much. And this is the things that I always try and take into account when I'm recommending a solution. This is the easy one. I don't need to go into this. Is it going to solve what it's going to solve? This is the fun bit. I've got a billion examples. If you want to talk to me later on at our stand about it, there's loads of solutions over there. That's the fun bit. I don't need to talk about this. And as I said, how's it being assembled into the product? It could be something as simple as, okay, it's a component. Is it on a tape and reel? Is it a capacitor on a tape and reel thing? Okay, well, that's quite easy. That's how it's going to be put on in pick and place. Is it something that needs to be a hand operation that could be done in a different way? And I'm going to give an example of this. So these are some spacers. It's just a plain old spacer. Okay, I've got an enclosure. I want to put a PCB on it. Okay, it's easy. I'll just choose any old spacer. Google spacer, top result, buy. But then, of course, when that gets to the production stage, later on, someone is going to be putting that PCB on top of these spacers. Now, if you chose a spacer like this, okay, that's fine. They'd have to have a screw and they'd have to balance it in the right place and put it on. That's fine if that's what you want to do. And the other way could be, say, if you had a pillar, a bit coming out of it, which means they would slot into it. Whichever solution is best is up to you. But all I'm saying is have a bit of consideration when you're choosing whatever component and try and think about that for the next stage, because that is one way of actually saving costs, is how things are being put together. The time that it takes for your production to actually be completed. Or it could be take a cable harness. It can be as simple as, imagine it's a larger device, take a tank or something like that. So it could be a case when that person is building the tank, this is further down the production stage, they'll have to reach in and they'll have to reach out and twist this on in a certain way, which might be difficult. Or you could just have a right angle or some type of component like this that you can actually change the angle. And that could be the difference between it taking a few seconds to attach it to several minutes. And then, of course, if you add that up, then you've increased the cost. So that's what I'm saying. Try and think about how your component is being added into the product later. And also, I'm finding enclosures is one of the last things that gets considered, which is normal. You would do the circuit diagram first of all, and then you would think of the 3D design, then you'd do the layout, and actually, maybe not completely decide on exactly the right enclosure because you might want to make it as small as possible, your device, but have an idea, what type of enclosure is it going to look like? And that's something else that I'm seeing issues with that could be just prevented, just helped off, because what did I say earlier on? The easiest time, the most cost-effective time that you can make changes is right at the start here. So just try and consider these things when it's happening. Then these parts here. Is it cost-effective and where are you buying it? I'm going to use an example from one of our suppliers, which is called Hammond, that are actually at the show as well. This was a few months ago. I was helping this engineer with one of our fans and then with one of their enclosures, and then on the end of it, they had to have a machined out part in order to have holes for the fans. If you're buying an enclosure, you're probably going to need a hole in it, let's face it. So then they came up with this design, and they had sent this out to multiple different people to try and get the cost. Now, this passed to their procurement manager, the drawing. Procurement manager does what you'd expect, sends it out to multiple people, gets prices back, and it was quite expensive. Then they got in touch with the other FAE from Hammond and myself. Oh, sorry, I've forgot something, hang on. One of my favorite examples, this can showcase how people like myself and how other applications engineers around here, Javier over in the corner there, can assist you with it. If you imagine you have a technology company, what's it not working? This is where you'll have, like in this audience a second ago, you've got the project manager and you've got the different types of engineers below it. And you're all in your individual niches that are useful for the team, which is what's required. And then in a rugby team, I used to play rugby a lot when I was younger. Anyone else rugby players or used to play rugby? Quite a lot, yeah. And in this, you have different specialist types of position. Anyone watching the World Cup? I can't believe there's only 3 people. Anyone else watching the World Cup? No? Okay. You have these people which have specialist positions, and then the sort of coach that overviews it. Now, this is me at the back here. I was this guy that played at the back of the scrum. My role was to go around and help people as much as possible and run around and try and help. Funnily enough, look at the career I ended up in. What a surprise. Now, I was also coaching my university at the same time I was playing for Isha. And I don't know how to coach this position, which is the props right at the start, right at the middle of it. I've never played this position. I don't know how to coach it. So I went to the head coach. This is Mike Schmidt, who was the head coach of Isha. And I asked him, I was like, Mike, can you help me out? What's the best way that I can learn how to coach this position? To which then he said, Robert, don't you get it? Ask. And he reached his arm out and pointed him towards the people who were playing this position, that had played this position for years. That's all they did. Go over there and ask them to go and coach the team for you. I went over there, I offered them a couple of beers. Hey, would you come down a couple of times a season and coach these guys how to do the scrum? They said, no problem at all. And that's pretty much what you have with multiple people here, that we deal with certain niche parts of product design every day. That's what we do. So feel free to ask. You don't have to go off on your own and go out there and spend months and months becoming an expert on every single niche of something. There's people here to try and help you. And this is where, going back to this example, this was shown to Russell, he's called, who works for Hammond. He took one look at this and he was like, why are you milling these out? These are going to be really expensive. So every single corner that's here, if it's going to be milled out, well, you're going to have a drill and it's going to have to go through, and then you're going to have a smaller drill, and then that's going to have to try and drill it out, and then an even smaller one, and it's going to be round holes. And the time it would take the milling machine would do that would take a while. And cost was an issue with it. So he said, why don't you just have lots of holes instead, circular, because then they can just be drilled out by the milling machine. And this dramatically reduced the cost. And this was just at the start of the design phase, when they were working out what they could use. A very quick conversation, like 10 seconds it was realized what they could have changed, as opposed to going through that procurement exercise and all that time taken trying to reduce the cost by going out to multiple people. And this is just a simple example of what you can do. And the things that I realized, if I just go back, was the 4 things, which is, did it solve what it had to solve? Yes, it did. The second part was it. How is it going to be installed into the production? Well, it's going to be part of this enclosure. It's going to be put together. Was it cost effective? It wasn't, but we found a better way of doing it. And was there a line of procurement? Yes, because they'd reached out to 2 different people and then that had been solved, which then meant when it gets to the production phase, it was all streamlined and it was easy. My very first design change was when I worked at Sony. And I was working on this, I realized next to the tuner, there was an amplifier which was giving the power supply to the tuner. And I realized after you turn off the TV, it was staying high. So I knew that there was a problem here. And actually when I tried to desolder the amplifier to try and change it for something else, I kept blowing up the amplifier because it was staying high. It was discharging through my soldering iron. So then we worked out, well, we're going to have some type of pull-down resistor, quite a high value, so therefore the charge could be removed over a few seconds, say when the TV had turned off, because it wouldn't have been safe to leave this charge on it. So what we did, I looked at what other components there were on the board. So what would have solved it? What was the first point? Does it solve what it needs to solve? Well, yes, that would have been one problem. How is it going to be attached? Well, it would have been on tape and reel, like all of the other components. Okay, that's fine. That wouldn't have added an extra production stage. Is it cost effective? Now, I could have just chosen any resistor value, but instead, I looked, what else is there on the board? Is there anything else that could have solved the same problem? And I found there was a nice 32 kilo ohm resistor, which was also on the board from a completely different department. So then I looked at this, and the reason that it's so important to find something else as well to make it cost effective, in Sony, we were making 5 million TVs. So if I added 0.01 pence of a 32 kilo ohm resistor to a TV, I have cost the company 50 grand. So this was actually a big thing that I had to consider. Was it cost effective to add this? It had to get signed off. And the other thing as well that I learned from this is that they put lots of 0 ohm resistors. They'd built in contingency. And this isn't just for this example for PCBs, it's the idea of later on in the project cycle as we go on, so when we're starting all the way down here and we're starting to get to know the design, they built in contingencies. By having these 0 ohm resistors, it meant if we needed to add something, then we could quite easily. So we didn't have to redesign the entire PCB, it was actually quite a quick design change. So that's the other lesson I've learned from back there. Try and think, if I had to change something moving forward in the design, is there a way that I can design my product to do that? And finally, was there a way to buy it? Yes, that supply chain would have already been there because it was a component that we already had. So it solved those 4 things. Saying that, in Sony, life wasn't perfect. This is actually what I used to work on. This is the tuner around here. And once I had to change this module. I had to completely remove it and put another one in. I destroyed about 3 of these prototype PCBs because I had to put a 300 degree soldering iron around the pins. There's like a 20 odd pins around the base of this holding it in. And I had to put all this I had to put all this heat in to try and remove this, which funnily enough upset a lot of the components around it. The problem, because it's a massive piece of metal, it's a heat sink. So it was just drawing all that heat away from the soldering iron. And so it was extremely difficult to remove it. So going through the four things. Would this shield can solve what it needs to solve? Yes, it does. It was a good EMC protection to stop the RF frequencies that are coming into it and then being removed in order to shield it from the rest of the TV. Yes, that solved it. Was it easy to add to production and for any maintenance? No, it was awful. And they still use these now, and that's fair. It's something they've been using for years, but it's not the way I would have designed it from scratch. And one example of this are these shield cans here, which are from Harwin, which I don't know if you've seen, but this is exactly a perfect example of how things can be designed for that production stage. These are pick and place little clips. They get added in tape and reel, and then you pop the shield can over the top. And you think the cost it saves from not having to remove the pins from any maintenance, the issues. Oh, if I had this, it would have been so much easier. All of that desoldering wouldn't have existed. I just would have popped it off. If you want to see them more, they're over there on our stand. Why is this not moving on? Another point. Things don't last forever. This is moving more on where things are going to be purchased from. Where is that supply chain? It's quite often, because people don't like change, if you move to a new town, a new city, people will tend to go to the same coffee shop. We all do it. I've lived in multiple different places. You go to the same bar, the same coffee shop, the same 1 or 2 places. You'll move somewhere else because people don't like change. And that's where people might design something from scratch. Then it'll get to next year and you're designing the next product. do you know what? I'm going to use the same component as I used last year because that's easy. Then it'll be the following year. Do you know what? I'm going to use the same component. I'm too busy to look at it. I'm just going to use the same one as last year. And then next year, and you use the same one. And you continue this for a while because you know the component. It's change. I don't want to change. It's effort, and it will make a lot of issues. But then, after a while, you could be the only person in the world using this component. And this is what happens. And if you think of manufacturers, they want to push the technology further. A good example of this is the footprints on a microchip. So lots of people, the microchips want to get smaller and smaller and more powerful. And sometimes the footprints have to be made big just because someone's designed the PCB with a bigger footprint. So that's where I was thinking, how can I describe this to you guys? So, okay, every time you're choosing a component, make sure it's readily available. However, this can be a myth. So the false piece of security that people can have is, oh, do you know what? I'm going to design a component. I'm going to look on Octoparts or something like that. Oh, there's loads of stock in the market. There's 300 of them in the market. Right, okay, I don't need to worry about this. There will be stuff available. But what's to stop someone else from another company in Australia, other side of the world, buying those 300 parts? You've designed this into your product at the start. You've got through to the prototype stage later on. And then you don't have no parts. You can't procure it because they've gone. And then the lead time is really long. So this is where readily available actually doesn't solve it. This is where I encourage you, speak to the manufacturers. There's loads of us out here. Speak to the manufacturers, every single part you put in. Don't be that person that causes the problem. And this is why I would say, before you sign something off, when you finish that first prototype, when you're thinking, right, this is now formalized, this is on my drawing, right, I'm pretty sure I know this is what's going to go to the next stage of the prototype. Have a review of that. Reach out to the suppliers, reach out to a distributor that you trust, reach out to someone that can do a check and say, whoa, I wouldn't use that one because that's only been sold to 2 people, and that's where there was 1,000 in stock, and they bought 996, and the 4 that you bought, you're the only people in the world. Use this part instead. And here's a perfect example. I worked on this a while back with a tier 1 military company, and they designed in this part, and they needed 2,000 of these. And I can tell you within half a second, I know that the 22 on the end of the part means that it's tin lead plated, because I worked with this stuff every single day, right? It's just normal. Unless you're in a specific aviation environment where it's required, where you don't want something ROS compliant, you don't need this plating. Next to it on the board, there were tin-plated components. There was no advantage of having this, and yet exactly the same size, shape, this would have been able to be designed in. And there was loads of stock for this. The lead time for this was 26 weeks. But because by then, it had got past this part at the bottom, when it had gone through, it got all the way to the testing phase, it's gone to the procurement managers who's going out to reach for it. Oh, and now suddenly we can't find that part. It was too late to make that change. It would have done and it would have brought people back off of other projects. It was too late. And it was such a shame. So this huge issue and this delay of 26 weeks of the project could have been avoided in about 10 seconds right at the start. And it breaks my heart when this happens. Like I said at the start, you are powerful people, you design engineers. The people at the start, those procurement managers, if you can review that bomb at the start, this type of issue can be gone. And this is why there's actually an industry called hard to find parts. If you touch hard to find parts on Google, you will find tons of them. There's probably people around here, and I have friends who work in this industry. They're lovely people. That's what they do, hard to find parts. But then this is where they get expensive. This is where maybe you have to procure it from sources you're not really sure of. And then you get headlines like this. This is about a week old, this headline, or a couple of weeks old. This is where it's been so desperate to find these parts, they started looking at other places, and there's counterfeit parts. It got found out by their end customer, and now they're being sued. Now, if this is a design that's 20, 30 years old or something like that, and it's a repeat buy, okay, fine. But don't let your new design that you're working on now, don't let this be the issue that you've got in 3 years' time when you talk to the genie. Don't get yourself in this situation. And you can do that by doing some very simple steps at the start, as I was saying. Another example that I've been helping out someone with, a very senior engineer, a principal engineer at a very prestigious military company, actually. he keeps reaching out to me every now and again for this $1 part. And I say the $1 part, hey, look, the end device that they're making is worth several $1,000,000, right? We're in a type of world where there's lots of military requirements at the moment. And this guy's always reaching out to me and he's looking for a little switch or a little connector, a little O-ring once, which is worth like 50 pence, right? So the $1 part, I mean a tiny component that is nothing in compared to the price of the entire end product. He even has this thing where he gets stock of something, he puts it on his shelf, ready for him to make his prototype, and then someone else in another division will be looking for a part. Oh, I need a part. Is there any stock in our place? Oh, there's 50 of those. So then they go down to the warehouse and they literally take away those components from that guy, and then they design it into their new design. So this thing that's hard to find, because he's got it in stock, he'll take it. So I mentioned to this guy, I was like, why don't you do like this type of kitting? Why don't you outsource this to like distribution so you haven't got this type of issue? And this is where if you work with a cable harness company or you work with a certain type of distributor like we do, this is where instead of having all these individual parts and then you're worrying about it, why don't you like outsource that whole thing to the same people and say, right, this is my whole one part. And then it will be sent in a bag or a box as all one part, and then that gets shipped onto the manufacturer of the cable harness or similar. And it's the idea of protecting yourself. And then if there ever is that issue of finding that $1 part, finding all that issues, you've outsourced that to other people and you don't actually have to worry about it. And if you think people like myself in this type of industry, or it could be any other type of component that you're working on, they deal with this stuff every single day. And that means this type of principal engineer that I'm talking to can spend time on engineering his product rather than hunting around for this $1 part, wasting ages of his time and his talent. Now I'm going to give a couple of examples which are closer to this production date. So this is where, fine, we've made the design, we got to the prototype, and for whatever reason, we've now got near the production date. It's about our testing, or maybe just over it. What could we do now to change? So 2 examples that I've worked on. This is where there's been quality issues. This was just after the production date, when they'd started actually making things in high production. And what I found is that there's hostile conversations at the start. I think it's human nature. We all try to defend ourselves. And what I've always tried to do is just be humble, matter of fact, focus on what's actually happening. People try and blame others and do that, and it doesn't actually help the situation. And when I've gone into these meetings, it's been like, you know, going into the lion's den, and I'm like, well, let's just work out what happened, right? And the best way I have found, and this comes from a very good quality manager who was my first manager at Harwin actually, is you focus on the procedure. And by that, I mean, if there's an error, if something goes wrong in your production, don't blame the individual that might have made the problem. Blame the equipment that he had. Blame, was he taught, or was he or she taught the right way in order to do this? Was there any contingency to make sure that wouldn't happen? And this is where you do something called walking the line. So this is what I did in both of these cases. So one of this case, it was about these pins were being scratched, and then they were sort of being corroded over time. This is what was being seen after the production and complained by their customer. Why have these pins got all rusty? And we were supplying these pins, which we didn't understand either. It's the only person in the world this is suffering with, and we supply these to many other people. It was strange as well. It was quite a hostile environment, so I just went in and we walked the line. And the other example was where the components weren't being put in by the machine properly. There was something wrong with the actual assembly of these parts. Walking the line, you do this. Even though you think it might be irrelevant, where are those parts coming in from? And this is a metaphor for other ways as well. Look at right at the start of any procedure, which later on down the line could cause a problem, where you're seeing the end environment. Start from the very beginning. How is that being procured? How is it being put together? Let's go to the main door. Right, it's coming in. Has it been somewhere else? No. Okay, where is this box opened? Well, it's opened by this person, by this knife. It's put on this trolley. Is there anything that could have damaged the part here? Of course, there's chances are it's minimal. They open loads of boxes, but let's just make sure. And when I've gone to these factories, so one was in Germany and another one was over in Slovakia when I had to do this, And I just took photos of every single step going on. Then it's put on this trolley, then it's wheeled over to this place. Now, the one with the pins that had this type of corrosion, where they were being stored was really close to their plating shop. And when I walked in, because I'm probably not used to being in this building, it was a very pungent, strong smell. Has anyone worked on a plating shop or knows what I mean? Has anyone been near one, near all the baths and that? Anyone else? I know Javi has, yeah. And you get all these acids and you get these other chemicals that are going on. And of course, that's not where the product was designed to be stored. And it was open and it was left open. And this meant that after their product had finished, after it had gone through some type of damage, it was then oxidizing because of these type of chemicals in the air. They were being stored there for quite a while. It's something that we weren't expecting to happen. The product hadn't been designed for that. Not only that, the way in their method was that they were taking it out of the tubing, they were putting it into a box, which was then scratching it. And then the way that they were inserting it into their component, the jig had not been designed correctly, so that was also causing some scratching. It's sort of irrelevant, the actual thing, but by going in and being humble and just being matter of fact, I saw a few issues. And actually, that's what solved it. And this argument went on for months. And the other example that I spoke about, I did the same thing, walk the line. Right, where are the boxes coming in? Okay, what trolley are they going? Are they going on here? Now they're being over here. Are they held by anyone else? Nope, then they get put into this machine. And we realized actually the problem was with the packaging. So we fixed it. Because otherwise you can spend ages trying to solve a problem which isn't the actual problem. So that's what I would suggest as well, this type of walking the line. And this could be any other thing when you get a problem in your design, something not going right, start right at the beginning. That is the way that you can be thorough to make sure you're actually fixing the right thing. And then also I'm going to talk about this solution. So this is where you've got to the production stage and it's failed that last test. And there are some lovely solutions out there that can help you with this. So this is where you could have failed an EMC test like this. So you can see here there are two errors that are going in here. And this is where you can have where you believe the source of the interference is. This is essentially a circuit board, which is on a piece of rubber, and it gets inserted into the connector. This gets turned round in about a week. You plush it in with the same connector, and it reduces massively the interference. And this is another example of where you can use a component to solve things at the end. But of course, the plan is, right at the start, we try and do our testing and we try and solve it here. But I am saying if the worst happens, there are some solutions out there in the market that can try and solve this. Start again. Whoa. The very best timing, if you did want any help from anyone in here, and there are multiple different people, the best time is when you're right at the start saying, I have a design problem, I need a solution for it. Help is the best way that we can do it, because then you've got more chance of considering the 4 things that I said, which is, does it solve the problem? Is it readily available? How is it going to be inserted into the product? Is it cost effective? And where is the line of procurement later on? And that can all be considered at the start where there's no issues. And then all of these problems that I've described cannot exist. And you can solve it and you can get rid of it and not have that problem with the genie further down the line. That's how I would suggest make use of the resource. And the final thing I wanted to comment, I thought I'd finish this way. So who's watching the World Cup? Who's watching the Rugby World Cup? Right, so this is about a week ago. Tonga were playing against South Africa. Okay, the scoreline was terrible for them. However, this one player, because of injury, he was called up. He went off the bench, and this is the first touch that he did. He got the ball, he kicked it forward like this, and he scored a beautiful try against the winners of the World Cup the last time. It was beautiful. He made an impact, the one chance that he had. Now, where is Pat Pellegrini homing his skills? Where is he based? Where is he improving himself in order to make himself a better rugby player? Coventry. He plays for Coventry. So if that doesn't give you reassurance that you're at the right exhibition in order to learn and improve yourself, I don't know what is. Thank you very much for that from everyone at the Powell Electronics team. If you have any questions, I encourage you to come over to our stand, which is right over there. We have the experts on specific other products that I'd want to talk to. So please make your way over. I would love to have a conversation with you all. Thank you very much.